Hi everyone. Last time in the previous lecture we discussed about energy, what is energy, and two broad categories of energy, like as you can see, kinetic and potential energy. And then the factors that affect the energy, like for kinetic energy, it was mass and speed of the object, and for potential energy, it was mass and position of the object. And then we studied various types of these subtypes of these energies, so kinetic energies and potential energy. Okay. So today we'll take it further and we'll see how energy is transferred. Okay. And to explain that, I will use this thermal energy. Thermal and heat energy are interchangeably used. Heat is basically transferring of this thermal energy. Using this energy, we will understand how energy transfers, okay, from one place to another. Um, let's run with some slides. Okay, so today we'll know what is energy transfer, which is movement of energy. Then we'll see how energy transfers. So when energy transfers through solids, it is called conduction. Then what is a convection? And what are convection currents? You will know that convection currents are responsible for some of the things like hot air balloon moving up, and then we will also see radiation, what it means. It is another way in which energy transfers. Okay. All right. So one thing to know is I gave you in the last episode an example where I am running and I then push you, and then that energy, that kinetic energy, gets transferred to you. Okay. Now let's understand a little more deeper with help of thermal energy this time. Okay. So here you can see that there is a energy. Now this is not ice cube, but what we are trying to say here is that energy flow in case of a thermal energy always happens from hot to cold. Okay. So if you the direction of energy transfer is basically from hot to cold, which you can easily see as if you, let's say, heat a metal, maybe let's say a big ladle of spoon in a hot recipe. You will see the bottom part of that ladle becomes hot first, of that spoon becomes hot first. But slowly that spoon starts to heat from the bottom, which is the most hottest place in that, wherever you are cooking, like let's say electric heater or a gas heater. And then it starts to go up towards the cool part, and then it also becomes hot. So you would have seen that thermal energy always transfers from hot to cold. Okay. Um, all right, and then we will see. So once we understand this direction, which is quite obvious, we will see how this energy is transferring in solid. So when energy transfers in a solid, it's called conduction. Okay, I'll try to sketch something for you. So we'll move here and let's make a solid. Okay. So now solid is a state of matter. You would have learned about various states. In solid, there are particles like atoms um, which don't really move, but they are very packed within a solid, right? Whereas in a liquid, they can move, the particles move, but not so much, right? They can, when you heat it up, let's say, you will see the water boiling as those particles moving. And in gas, they really move super fast and spaced out like gas. If you put some gas, let's say oxygen in the air, like it's everywhere, right? It just spreads. They are very loosely um, bounded particles, so to say. Okay. So coming back to our conduction, which is about how heat transfers. So let's say this is a solid rod, okay, and there are many particles in it, atoms, which are packed together. Now, when you start to heat up this rod from one end, let's say you put some Bunsen burner or another mechanism of fire here. What will happen is that this two atoms, let's say, just we take example of this one, they start to vibrate in place. Like they don't just move because they are not liquid or gas that the particles will move. They are jam packed. So they just vibrate in the single place in their position. And when they do so, they collide with the neighboring particle and so on. So they collide with this neighboring particle. In this way, they transfer this energy to the next particle and so on. So you see, so suddenly this part becomes hot. Then we said that energy transfer happens from hot to cold. So that's how slowly these particles, this particle doesn't move and come here. Okay, this particle remains here. It's a solid, it's not a liquid. It's just vibrating and in place. And then it's transferring that energy to the nearby neighbor, which is the neighboring particle and so on. And suddenly this whole thing will start to become hot from this side to that side, right? You would have observed something like that. So this movement of energy is called conduction when it happens in solids, and it's because of uh, the particles colliding with each other. Cool. Um, Not colliding with each other, but passing their transfer energy uh, between each other. Okay, so energy transfers through a material by direct particle interactions. Okay, so this is what is conduction. When heated particle, like you can see in this visual here, yes, that these are in place. See this one, this is vibrating and then it passes the energy across to the neighboring particle. Okay, when heated, the particles they gain energy, they vibrate more and collide with neighbors, passing energy along. And these collisions basically transmit the thermal energy. And then now there are some, like you would have, if you heat a metal, you will see that it becomes hot quite fast, yes. But let's say if you take another material, maybe let's take a wood, if you heat it, you can still hold the other side. It won't become hot. Okay. So some materials we then understand can transfer heat well. So metals like copper, aluminum, steel, iron, they are excellent thermal conductors. We call them conductors because they transfer heat fast. Okay, conduction, conductor, right? Then insulators are the materials which are poor heat conductors. Okay, we call them insulators. So you can just say that it is opposite of conductors, maybe. So plastic, wood, rubber, foam, these are like slow heat transfer. Okay. And these are called insulators. And I mean, so let's say if you're going in a hot desert and you are wearing a rubber flip-flop, they act as a insulation. So the heat transfer from the hot sand to your legs, um, they will block it because they are insulators. They are poor heat conductors. Okay. So that's how we understand what is a conductor and what is an insulator. Okay. So that's all about we need to know for conduction for now. Okay. We move on to convection, which is like transfer of energy in liquids. Okay, so how does it work? Let's see. So I'll again open my sketch, and this time we will pick the liquid in which the particles can move, right? Liquid, you drop your water, the water particles will move from one place to another place, right? If you drop a solid iron rod, it just nothing happens. Its shape is not deformed, right? So in case of liquid, um, let's take a liquid. Okay, so let's say this is a container filled with water. Okay, and now you heat it from here. Okay, so let's put our Bunsen burner here now. Now what will happen is this water here, the particles in this liquid will start to heat up. And when they heat up, they will move up because they can move. Yes, they are not like solids. When they heat up, they move up, and I'll explain you shortly why they move up. But okay, because they are being heated, they will be transferred from hot to cold location. Okay. So when they move up, they will push down the cold particles which are over here on the top to the bottom, right? And which will in turn heat up again because now they are near the fire. And once they gain that energy, they will move up. And then similarly, they will push down some more cold particles. And so you will see that eventually they all will heat up. But that is, you can see also like this is like a current, yes, water going up. Like current doesn't mean the electricity current. It's current here means that a river current, yes, you would know that the river is flowing. So it's like a flow. So you can already see that particles going up and the cold particles coming down, heated up coming down, the cold ones. This is already forming a current, a movement. So this current is called convection current. And this process of transfer of energy in liquid or gas, because gas will work similarly. Yes, you have a gas, it will be, if you try to heat it from here, they will move away. Yes, those particles are even loosely coupled to each other, like loosely bonded to each other. They will move up, then cold gas will come down. So so convection is basically energy transfer in liquids and gases. Okay, yeah, you can see the visual here. Basically, the hot liquid moving up and the cold is pushed down. Okay, so thermal energy is transferred when particles in matter move by convection, and this matter is liquid and gas. In liquid and gases, particles flow freely past one another, okay, carrying heat. So you would have seen a lava lamp, that colorful lamp, which often either you buy or generally I used to get it as a birthday gift, where there is a wax inside that liquid lamp. Um, Let me see if I can draw to refresh your memory with my bed. I mean, you would have seen there is that colorful something here, then there is generally that kind of top for decoration, and there is a lamp in the below, which you generally don't see, but maybe when you on it, you see that light. So that lamp basically is acting in this case like a Bunsen burner and heating it up. And the wax then goes like wax just floats. But basically, what is happening is that water is getting heated up, going up, making the wax to flow, then cold water coming down, and that's how those things move. Cool. So convection current explains this lava lamp burning. I mean, lava lamp function. Okay. Now, heat drive. So we discussed it that particle near the heat source gain energy and move. Heated particles rise from bottom towards cooler regions, and then you saw the convection current. Yes, like movement of this water is that current, water or gas. Okay. Now, um, let's talk about density a little because these are all related. Okay. What is density? Maybe just to refresh your memory, density is like you would have heard about population density in a area, let's say the same area. If there are more people living close by, we call it dense population. But if let's say there is one person, maybe one, two houses here, one house here, one house here, this is less dense. So same in um, like in matter also, if the particles are very much together, we call it dense, and the density is high, and then the density is high here, and density, and density is low in this one. Okay, so when you heat up, so let's say these are all, let's say, water molecules, um, and when you heat them up, they get energy, right? And then they start to move apart. So the move apart means their distance between them will increase. Okay, so let's say this particle goes here, this particle goes here. So here basically there will be less dense, uh, less density. And then the particles here are not that hot, so they are closer together in, let's say, in this liquid. And they are in that case like more dense here. you can just say that they are maybe more heavy. So they will come, so the heavier object will fall down, right? And the less heavier item will go up. So you can see that density plays a role in this convection current, right? So density decreases when you heat, and then the above particles which are less dense falls. I'm sorry, the above particles which are more dense falls down. Okay. So this should explain that in a hot air balloon, um, like in a hot air balloon, when you heat it, yes, you would have either taken a ride yourself, or you would have seen it in videos that when you heat it up, um, what happens is this becomes less dense. The air here becomes less dense. They move apart. This air is a gas, right? So these particles move apart, whereas the air here is more dense because this is not a hot air. It's like normal air. So, which means that this less normal air will come up, and this less, I mean, because, sorry, more dense. These are dense because they are not apart. Yes, they are not heated. So more dense air will come down, and this less dense, now the balloon will rise up. So that's how the hot air balloons go up. Also, this is a density and convection mechanism that explains how a hot air balloon moves up. Cool. So yeah, just to go through the slide, warm particles spread out, the fluid expands, and its density decreases, right? So when it expands, like they move apart, which means density is decreasing. Less dense warm fluids, this less dense fluids rises, yes, while cooler dense fluid sinks to replace it. This continuous cycle transports heat from hotter regions to cooler. And this is an example of liquid, but same is in gas also, yes, or air also, right? Gas, air is gas. Cool. So, yep, we saw this already. That cooler liquid or gases becomes denser and sinks towards the warmer region below. Cool. Um, all right. So that was convection currents. So we saw so far two mechanisms of energy transfer. One is conduction in solid, another is convection in liquid or gases. Now there is another third way which we call radiation. In this, like in the earlier two explanation, I used like those particles, yes, which were moving or vibrating in case of solid and moving in case of liquid and gas. So matter was required, like matter means these atoms, molecules, um, substance was required. But see, from sun to earth in space, there is no matter here, there is just vacuum largely. So still the heat, the light waves, the electromagnetic waves, they come from sun all the way to the earth, and that doesn't require any matter. So when energy transfers, and that is also heat energy, yes, earth get heated these days, particularly it's quite hot. So that energy transferred, light is an energy, yes, heat is an energy, it got transferred without matter. So when that happens, we call it radiation. Cool. So radiation is transfer of heat energy from one place to another without any movement or vibration of matter. Cool. So should be easy to understand now with that sun and earth example and no matter. Okay. So cool. So this light is an electromagnetic wave. We will learn what electromagnetic wave is, but at least the diagram should show you that it looks like a wave. Um, and it carry energy without needing matter. So like, and examples of this is not only sun's light, like even various microwaves, and we'll learn about waves in another chapter. But the visible lights, if you would have heard about them, like which you makes you see everything. There are lights which are also human eyes can't see. Okay, but visible lights, microwaves, other electromagnetic waves, they transfer energy by this radiation process. And an example would be infrared thermal heater, you would have seen it in, generally they are in hospitals also, but in home also. Okay, so in this like it's infrared heater like is heating the whole room here. It's happening not via particles movement or vibration, but via that electromagnetic waves transfer, which heats the whole room. It radiates thermal energy to heat a room efficiently. Okay, so this is an example and a application of radiation in general day-to-day life. Okay, before I conclude, I just want to talk about this, like consider paying uh, any amount dollar greater than equal to $5 will do. This is how you pay. If you pay, I'll send you this presentation. I'll send you some notes for this particular lesson. Example of one such note is like this, like based on question and answer. So what is convection? Uh, so the answer could be like if you want to make long answers. So thermal energy is transferred when particles in matter move by convection, and particles in liquid and gases can flow freely past one another, right? So when a liquid or gas is heated, particles move to take place of particles with less heat. So you will get a properly worded answer for you to be able to learn them. Now that you understand the concept, it will be easier for you to also learn and then write bigger answers for better grades. Okay. Um, then key terms we learned was conduction, which was transfer of energy through a substance being solid. A conductor is basically a substance that allows, so that that particular substance is called conductor. And then we learned about insulators also, which doesn't allow heats to transfer. Then convection was transfer of energy by movement of a liquid or gas, right? And some more terms like heat is the flow of, so heat and thermal energy we use interchangeably generally, but if you have to really define it, it's a flow of thermal energy. So heat is a flow. Okay. Insulator resists the transfer of thermal energy. Matter is a substance that has mass and takes up space. So anything is matter. You yourself are matter, and your laptop is also a matter. Okay, everything is matter. Radiation is transfer of energy that does not require contact with matter. So this transfer of energy happens without matter via electromagnetic waves. Thermal energy is the energy in a system that is responsible for its temperature. Um, and then some examples like sunlight does radiation, wood is an insulator, water is a matter, everything is a matter, and a hot cup is emitting thermal energy. Happy learning. Hope you enjoyed. Thank you.